Oh, hello. All right, what are we doing here? We're doing number 3B. No, we're not. We're doing number 3. What is that? H. I apparently need stronger glasses. All right, so what do we got? We have a 25 kilogram black box that is sliding to the right at 5 meters a second. So let's start there. Here's our box, 5 kilograms. It is sliding to the right at a velocity of 5 meters a second, which means that this mass is wrong. It was supposed to be 25 kilograms. All right. All right, so then what's happening? So let's see. Every time you make a free body diagram, you should start with, that is correct, your force of gravity. So I'm going to give myself a little room. Here we go. Force, whoa, all right, we'll do that. That works here. Oh my goodness, I am struggling here. Let's try again. All right, so our force of gravity is going to be negative 245 newtons. All right. Let's see, Roy pushes it to the right with 60 newtons. Force of Roy, 60 newtons. Sally's pushing it to the left with 100 newtons. Force of friction is 50 newtons. All right, so here's the deal. Which way does friction go? All right, please remember, friction opposes motion, not force. All right, the idea is the box is currently moving to the right. Okay, Roy is trying to make it go faster. Sally is trying to make it go slower. What is friction trying to do? Trying to make it go slower. All right, the idea is our force of friction is not going to oppose a force, it opposes a velocity. All right, the idea is our box is moving this way, so our friction is going to be that way, opposite direction. All right, so I can go ahead and put in my friction. The problem told me that that was 50 newtons. All right, so I think that's my free body diagram. Let's get rid of some of these extra colors that I've got here. Oops. No, I won't. No, fiddle faddle. All right, well, pretend the blue highlighting isn't there. It's not letting me erase. Oh, well, shoot. Now I've come this far. All right, there we go. Oh my goodness. Okay, so there we go. So those are all of our forces. Oh no, it's not. All right, so let's see, horizontally. I think all of our forces are taken care of horizontally, right? So our net force. So remember, when you consider your forces, you want to just consider either horizontal or vertical. All right, so right now I'm considering my horizontals. So my net force horizontally, I think we've got all of our forces, right? There's Roy, Sally, friction, and that's it. So force of Roy, force of Sally, force of friction. So what do we get? 60 plus negative 100 plus negative 50. Whoa. So our net force horizontally looks to me like it's going to be, what is that, negative 90 newtons? So now I can find, oops, this is all horizontal, right? So my acceleration horizontally is net force over mass. So negative 90 newtons over 25 kilograms. So our acceleration is going to be negative, what is that, 3 point something or other? 90 divided by 3.6, right? 25. Yeah, negative 3.6 meters per second squared. But notice that's horizontally. All right, but what's going on vertically? Right now, the only vertical force I have is gravity. Oh, right, but I know that my net force vertically has to be 0 because there's no vertical acceleration, right? The box is not going to move up or down at all, right? And so automatically I know there's got to be a normal force here of positive 245 newtons to cancel out my gravity. All right, so this is my completed drawing and information and stuff, right? I guess I should probably include the net force, right? Okay. When you give your answers, you don't need to specify if the net force is horizontal or vertical. Just know that within this class, your net force will either be horizontal or vertical, never both. All right. So there we go. I think that is that. Do you want to stop?